Hello and welcome back to the Ground Up Advanced Flight Tutorial. Thank you very much for joining me in this video, and today we are going to be learning about the last or the second to last part about using IFR charts and planning a route and doing some flight planning and getting from point A to B using airways, standard instrument departures, and for this one we're going to be looking at standard arrival routes, which are stars. So we're going to be focusing on stars in this video. Quickly to go over what we've done so far. We've had a look at these charts. So we'll start again on Sky Vector, simple VFR chart, simple low altitude airways chart, and a simple high altitude airway chart. We understood what all of these are, so we know that these are all airspace. We didn't go into what these airspace mean, but we know that these are all airspace. We know that this is military airspace or restricted airspace. We know that this is a VOR. We understand how to read that, what all this means, and just having an understanding of why these are blue, what this shape is, why some of them have arrows, some of them don't, what does that mean, so on and so forth. So we explained all that. Then we went on to have a look at an aerodrome chart, which we had a look at for Echo Golf November X-ray. So we had a look at an aerodrome chart and all the bits that are associated with that. So what all the markings mean, what all the icons, the symbols mean, and how to read one of them effectively and quickly to understand what's going on. From that, we learnt how to do a STID, a standard instrument departure, how to follow one out. We did the Daventry 4 Papa departure out of Echo Golf November X-ray all the way down to Daventry, at which we knew that we could join up to Mike 605, Lima 10 or Mike 189, therefore going to Papa 166 or Papa 155. So we understood that. That was all in the previous 3 lessons. So if you haven't seen those 3, please do go watch those first, because they have information that I am going to be using in this video that you need to know. So please do go watch those first. Also, if you really do like these videos, please make sure you're hitting that like button. Please make sure you're following and subscribing and leaving comments telling me that you do like these videos. On top of that, please do also, if you can, consider supporting me on Patreon. Link to that is in the description box below, and I'll mention it again at the end of the video. But for now, we're going to move on to the next part of this, which should be the second to last part. Like I said, we're going to be looking at stars in this video, and in the next video, which is going to be the last one of looking at charts, we're going to be looking at instrument approaches to a runway. So for this, we're going to be looking at an approach into London Heathrow. London Heathrow is one of the busiest airports in the world, if not the busiest airports in the world. Not exactly very big, so it means that there is a lot going on in a small area, particularly with the amount of airports we have around here. So that's a busy airport, that's a busy airport, that's a busy airport, that's a busy airport, that's an extremely busy airport. In fact, those two are both extremely busy, while City, Luton and Stansted are not as busy. So those are a bunch of busy airports. On top of that, we don't have to go too far up to find another busy airport, another busy airport, another very busy airport. So you can see that there is another busy airports right there. We have a lot of airports that are very, very busy, and we have a lot of congestion in our airspace. So that's why I've decided to show you guys London Heathrow, because it has interesting approach procedures and an interesting star. Again, we're going to ignore this over here. I am going to mention it, but I'm not going to go too much into detail as to what it is. But I'm sure by now you've probably figured out what it is. And on the star, it is labelled on the star, and you'll probably know by looking at that what it is. So let's pretend that we haven't taken off from Echo Golf November X-ray, that's East Midlands. Let's pretend we've taken off from Manchester International, Echo Golf Charlie Charlie. From Manchester International, we've used the Samba Departure. Now, the Samba Departure takes us out to this waypoint here, or a fix. We can call this a navigational fix. It takes us out to this one over here. Now, this is an RNAV one, as always, but it does also work on VOR. These are on the old systems as well. As you can see, there's one for Cosford, Crewe, Chase, Cedar, so on and so forth. But these ones do still work, at least most of them. Maybe Cosford doesn't work all the time anymore. Telber has probably taken over that one. But Samba is an RNAV is an on-air fix, but you can use it, like I said, in any other way. So we're going to use the Samba Departure. From the Samba Departure, we're going to go down, and we're going to go follow November 859 all the way down for 44 nautical miles to Honolulu. At Honolulu, we are going to join on to the Bovingdon, that is Bovingdon Star into London, and I think the one we're going to be using is the 4 Alpha. I think it's Bovingdon 4 Alpha that we're going to be taking in, but I can't remember exactly. It's got quite a few. So let's go to that page and let's see what we've got in front of us. So here we go. Here is the Bovingdon Star. As a matter of fact, let's do that and get rid of these. Just makes it easier to read. There you go. So 1, 2, and 3 is what we're going to look at. Now, let's start with this one, London Heathrow via Bovingdon. So there we are. So you can see over here, the first thing we've got is we've got a fix up here, the Nugra fix. Now that one is something we don't have to worry about because we're not using it. But I want to use this as an explanation, and the Lambourne and the Lambourne VOR as a little explanation to what these are. This sort of line that looks like, if you do electrical engineering or anything to do with electrics, you might think that that is a resistor. In a sense, there is a logic behind why a resistor has that sort of symbol, but basically all that means is that that is not to scale in the sense of what the rest of it is. So there has been a bit cut out there and a bit cut out there because Lambourne and the Nugra fix would not fit on this chart, but because they are both instrumental in the Bovingdon approach and the Bovingdon Star, they have to be put on the chart. So you get the furthest point you can, and then they use this little marker like so to indicate that that is not to the scale of everything else. It's further out, so it's probably out here, and similarly Lambourne is probably way out here. So that's all that is, nothing more to worry about. But anyway, we have this right here, Honolulu. So there's our Honolulu VOR. That's the one that we're joining from, or VOR DME. Again, same things as the other charts. Frequency, Morse code identifier, military channel that we don't have to worry about. What do you call it? Is a Vortac channel or TACAN channel. Anyway, and a GPS positioning. Very, very simple. It's the 4 Alpha approach that we're going to be using. So again, it's written just like a SID. And the information that is available is again just like a SID. So it says what it is, what the the organization is that has approved it. So it's an ICAO approach. Distance in nautical miles, magnetic radials, tracks, altitude, elevation in feet. That's where you're going to. That's the Star via Bovingdon. Dates and that we don't have to worry about. Any information that we need. So Heathrow Director 119725. Tower 118.57, 124475. Heathrow Radar is there, and the Heathrow ATIS 128.075 is the one that we use generally. And then we've got the transition altitude and the transition level by ATC. Now, it says here transition level ATC. That's something that isn't on the other one. This means that ATC will inform you of a minimum holding level, which is your transition level. Normally, it would be probably flight level 7. I think 70. Flight level 70, I think, is what they use for the transition level, and then it comes down to 6,000 feet. But that is by ATC, so you need to figure it out from ATC first. That will be available to you. So that's something that's dynamic. But obviously the altitude is the exact same all the time, so don't worry about that. And again, we've got the minimum sector altitude, just like we had on the other one, at 2,600 feet, due to mountainous region over here, a very hilly region, and lots of valleys and stuff in the Peak District area. And as you can see, some of these areas are rather flat. So that's completely okay. Right, moving on from that, we're going to explain the approach into this because there is a lot of lines, a lot of stuff here. What I want to first do is I want to tell you about these ones. We've got a Kennet coming in from a Kennet waypoint, Bovingdon 252, Bovingdon 1 Delta approach. Let's ignore that one. And we've got the Lambourne, Bovingdon 1 Echo from Lambourne. Now, Lambourne has its own star. So what are these, and what's this Kennet one as well? These two are for traffic. So when there is a lot of traffic, there are holding points before Kennet, and there are holding points before Lambourne. At Lambourne, there's one at Sabre, I think, and there's one at Logan itself. So there are a bunch of holding points at Lambourne that come into Lambourne, and I think there is a holding point at Lambourne. I can't be entirely sure of that, but I think there's a holding point at Lambourne as well. However, if all of them are busy due to the amount of aircraft coming into London, then what they will do is they will route people along the Bovingdon, or route aircraft and pilots along the Bovingdon 1 Delta and 1 Echo to get them into this hold here at Bovingdon. That's all it's for, and then they will do a Bovingdon approach. So don't worry about that one and that one. We're not going to worry about them at all. That suddenly makes this a little bit more simpler. We're going to ignore the Bovingdon 1 Charlie as well. That's in from Daventry. Now, if we were doing a short flight from East Midlands using the Daventry SID, then we'd go straight from a SID to a star. So you'd get up to 9,000 feet, and then you'd probably come down straight from 9,000 feet. Or whatever it's going to be. So, moving on from that, let's follow in this one here. Honolulu 141 radial, 411 nautical miles on the Bovingdon 4 Alpha approach to the Tobid fix. Then Honolulu 1 radial 144 for a further 21 nautical miles. That is the Bovingdon 4 Alpha and 1 Bravo approach. So you can see that these two have now merged into one approach. 21 nautical miles to the Soppit fix right there. Again, it gives you information over here as to the GPS coordinates of the fix and the nearest VOR that it wants to be using. So for this one, it's very obvious that because it's on that radial, you might as well just use that. And you've got the radial 140.9, so that's the exact radial for it, and the distance marker 31.6 nautical miles away. So you can work that out for yourself. So that's what you got from Soppit. Then we've got a further 8 nautical miles on the 4 Alpha and 1 Bravo approach to. Now this is where it might get a little bit confusing. This is the Westcott NDB. So this is actually a non-directional beacon, as you can see from the sign which we learnt, or the symbol which we learnt a couple of lessons ago. So Westcott NDB, that's its 3-letter identifier, that's its frequency 335, there's its Morse code again, and just like normal there is its GPS coordinates, but of course it's not a VOR. So you come into the Westcott NDB. Now at this point is where you are going to turn to the Bovingdon VOR, unless you need to do a hold. Then you're going to join one of these holds depending on what's been given. So for example, on this one, below flight level 150, you're in this hold. Above flight level 160, you're in this hold. So that's something you need to be aware of. So there you go. You've got one hold there and one hold there. Once you've got through those holds, if you don't need to go through those holds, and those holds of course are when there's a lot of traffic, aircraft just circle round and round and round at a height given by ATC. And you can see here, if we just quickly have a look at this, holding speeds, maximum holding speed in the LTMA, that's the London Terminal Maneuvering London Terminal Maneuvering Area. So that's what that is. Up to and including flight level 140 is 220 knots indicated airspeed. At flight level 150 and above, standard ICAO holding speeds apply. The London Terminal Maneuvering Area, or Terminal Control Area as you might want to call it, is the area around London. Because of the amount of aircraft that go around this area, this is a special airspace around London that has routes going in, out, left, right, all around the place, and it extends pretty high up and goes all the way down to basically the surface. So it's a special control area, and in many places it does go down right down to the surface. So I think the London control area is handled pretty much out of Daventry. At anything above 10,000 is London control, and then all the way down here towards Heathrow it goes right the way down to 2,000 feet, and then it goes into the Heathrow approach area and city approach, but then all the rest is also under some sort of ATC. It's a very complicated area, but don't worry about that. When we learn about airspaces, I'll show you these areas. Again, We don't need to worry about this either. We've seen what this is, so I'm not going to explain that. Again, warning for minimum descent rate requirements. Don't worry about this. See the ENR 11 paragraph 3.2. Don't worry about that. But this is an important one. Warning, do not proceed beyond Bovingdon without ATC clearance. So you can see that at Bovingdon, so let's say we've gone from Westcott and we've joined up on the Bovingdon radial 298 on a track of 118. That is now the Bovingdon 4 Alpha, 1 Bravo and 1 Charlie approach, 17 nautical miles to Bovingdon. At Bovingdon, there's nothing but a hold. There is nothing to get you in to London Heathrow from there, so we're going to have to switch charts very soon. The only one more thing that I want to explain on this is this point here. Now I'm going to use this one on the 1 Delta to give you a better explanation because you can't really see it there. But it's got these little stars, these 4-pointed stars, not with a circle, just a 4-pointed stars. And it says, on this one it says Bovingdon 1 Delta SLP. On this one, Westcott NDB SLP. SLP stands for speed limit point. At that point, you must be slower than 250 knots. So unless you're in a hold, if you're in a hold, it's different. But if you are continuing along these approaches, you must be slower than 250 knots. Now, you're probably wondering, why doesn't Lambourne have one? Well, it does. It's actually about 7 nautical miles behind this map. So behind Lambourne, I think it's 7 nautical miles out from Lambourne, there is a speed limit point for Lambourne at 250 knots. That's why that approach doesn't have one. Other things that you need to know, you can see that these are very obvious now that you know what these are. Flight level 160 and above, flight level 150 and below. This one here, the hold 7,000 feet and above. Now you might be wondering, why is that not flight level 70? That's because of the transition level that is by ATC. Like I said, it might be 7,000 given to them. So, or they may be telling you 7,000. So that is not a flight level at this point in time. That is actually 7,000 feet. So there you go. Other things I want to mention that's not shown on this map, there may be points where there are numbers written. So like for example on this, it may have at Soppit, it might have a number written here saying flight level 120. What that means is that it's not telling you to make sure that you get to flight level 120 because there isn't a line above or below it. And below it, that would be saying get to that point. If it's above it, it's saying be below that. If it's below it, it's saying be above that. It might just have just a number written. That's a recommended descent profile. So there is recommendations over here on this chart that can be written on the chart. So let's have a look, for example, here. We're using the 4 Alpha. So arrival via Lima 15. Flight level 150 to 190, Lima 10, flight level 140 and below, Lima 612, flight level 90 to flight level 140 to Honolulu VOR. And we were using a different one. We were actually using it from Samba to go to Honolulu, which actually is in November 986 or whatever it was. To the Honolulu VOR, continue on Honolulu VOR radial 141 to Tobid, then Soppit, then to the Westcott NDB, turn left onto Bovingdon VOR radial 2908 to the Bovingdon VOR, and then it gives you the recommended flight level. So flight level 150 by Soppit is what it wants there. That's recommended for Heathrow. If you're going to Northolt, which is an RAF base just about there, they want you to have flight level 150, 5 nautical miles before Soppit. So if we just go to SkyVector, I can show you where Northolt is. Northolt is just there. There's the RAF base, RAF Northolt. So there we go. So that's the information that it wants. And for something like 1 Bravo, it tells you that by Tobid, you want to see higher up and then coming down lower afterwards. So there you go. That's all the information that you need. And then here's the last bit, the general information. Standard routes may be varied at the discretion of ATC. Because of the amount of traffic, ATC might tell you to take a different flight level, climb, descend, turn left, turn right, whatever it wants to do. You then follow them. You don't follow your star, you follow what ATC say. Cross speed limit points or 3 minutes before holding facilities at 250 knots or less. When Bovingdon VOR is out of service, the route will be to Bother. Now, Bother is this one right here. So see here, it says VOR Bovingdon U/S. That means unserviceable. It's pretty much the same approach all the way in, named differently because the VOR, which is somewhere right there, is out of service. So what you need to do for this one is use the Biggin VOR, which is down that way. You can see the Biggin VOR down that way. So you're using the Biggin VOR to figure out a fix for this. So it's a radial 1, it's radial 317.9, distance 32.3 nautical miles away from the Biggin VOR is Bother. It's also, as you can see, that way from Westcott, so 117 from Westcott, so that's how you fix it in. So you go, right, it's that way and that way, so that's how you know where it is. Pretty much simple, everything else is exactly the same. Now, going back to this one, you'll see that en route holding at the Honolulu VOR during periods of congestion in the London TMA, traffic from the north may be required to hold here. So they might even tell people, just go over here and turn around. So, for example, anyone coming in from this on the 1 Bravo might be routed to the Honolulu VOR, do a hold around the Honolulu VOR, and then join the 4 Alpha approach, whichever way they're going. So, below flight level 20, that way, 200, that way, above flight level 200, that way. So on and so forth. That's note number 4. As lowest level in Bovingdon holding stack, 7,000, is above the transition altitude, there you go, there's the holding stack, right, but it doesn't give it as a flight level. Aircraft will be instructed by ATC to fly at the appropriate flight level. So there you go. So with this at 7,000 feet, it is 7,000 feet with whatever the actual barometric pressure is, but because it's above transition altitude, they'll give you a flight level to fly instead. So they may say flight level 7.5, so that, or they might say flight level 6.5, depending on the barometric pressure, to give you roughly 7,000 feet. The routes shown also apply to aircraft inbound from inbound to Northolt, which is the RAF base, and Denham, which is Gerrard's Cross. Which, if we have a look here, there's Gerrard's Cross, Denham. Going back onto that, last but not least, in order to provide airspace management flexibility during periods of congestion in the London TMA, stars Bovingdon 1 Delta and Bovingdon 1 Echo are to facilitate the transfer of traffic between terminal holding facilities. These stars are for use only as directed by ATC and must not be used for flight planning purposes. So when you're doing your flight plans, you do not assume that these two are going to be used. So you can't go from Kennet on the Bovingdon 1 Delta or in from Lambourne on the Bovingdon 1 Echo. For Lambourne, you want to be using the 3 Alpha, and for Kennet, I can't remember what the one is in from here, but you want to be using, for example, 3 Alpha coming in from Lambourne, and then use these ones for Bovingdon. So Bovingdon, as you can see, is only essentially from the northwest. That's what Bovingdon is used for. Hopefully that makes a lot of sense to you guys. Let's move on from that to the next bit, and this is going to be have to be done nice and quickly. So we've covered this. Let's get on to this. This is the initial approach procedures. I've selected ILS runway 9 left and right without radar control. So radar control is vectors. Vectors is basically the ATC telling you where to go. So what we've got from Bovingdon, you've now reached Bovingdon. It is now telling you to follow this in. This is no longer a star. This part here is very simple. Bovingdon 179 radial down. We've understood this. Bovingdon distance marker 5 to the minimum holding level. Minimum holding level will be assigned by ATC again for 7,000 feet. Then you come around this way and you're going to join on to the Lambourne VOR. So the Lambourne VOR radial 265. 265 again holding the minimum holding level at the Lambourne distance marker 30. Bringing it in. At distance marker 34, you need to be above 6,000 feet and turning. Now this one is interesting because you have to tune in 3 different VORs. You've got this VOR, Bovingdon. You've then got the Lambourne VOR. Then you need to tune in the Goodwood VOR. Radial 359 on a track of 179 all the way down. I'm not going to explain this one. Obviously, that now makes sense to you guys, having seen SID charts and the initial star chart. Then we come in down here. IAA, IBB, those are the locators for London Heathrow. As you can see, those are the locators there. There are the frequencies 110.3 and 109.5 for runways 9er left and 9er right respectively. And this point here, FAP and FAF, final approach point, final approach fix. That's at distance marker 7.5 nautical miles away from Heathrow, and you need to be at 2,500 feet. So there you go, and you can see that 10 nautical miles away, you need to be established on that, and by this time you should be on the localizer 3,000 feet away from it. Very, very simple. And you can see here it tells you from Lambourne or Bovingdon. Since we came in from Bovingdon, leave Bovingdon on the 179 radial, maintaining minimum holding level at Bovingdon, which the minimum holding level is 7,000 feet, for example. At Bovingdon, distance marker 5, turn right onto the Lambourne VOR radial 265. At Lambourne, distance marker 30, descend to cross Lambourne, distance 34, not below 6,000 feet. At Lambourne, distance marker 34, turn left heading onto the Goodwood VOR radial 359er, descending to cross Goodwood, distance marker 39, not below 3,500 feet. At Goodwood, distance marker 39, turn left onto the localizer for runway 9er left or 9er right as instructed by ATC, descending to 3,000 to be established by distance marker 10, as I said. And then last but not least, at distance marker 10, you descend to 2,500, then continue the ILS DME or localizer DME instrument approach procedure as detailed on the instrument approach charts. Absolutely simple, not a problem. And you can see here more general information. The minimum holding level, which is the flight level equivalent of 7,000 feet, is above the transition altitude and will be allocated by ATC, as it says here. Initial approach procedures are designed for maneuvering speeds up to 220 knots indicated or speed limit specified in the procedure, and assume aircraft can maintain a descent gradient of approximately 320 feet per nautical mile, which is a 3-degree descent. So if you watch this from about here, that's a 3-degree descent all the way in, so it should be absolutely fine. Continuous descent approach should be used wherever practicable unless otherwise instructed by ATC. So that's what that's saying is when you get to this point, and let's say you're at 7,000 feet because the transition altitude or the transition level is exactly 7,000 feet. From there, you don't want to go down to 6,000 feet by here and then hold 6,000 feet, then go down to 3,000 feet by 3,500 feet by here, then hold 3,000. You want to pass these at the right point all the way down. So you want to be just above 6,000 here, just above 3,500 here, at 3,000 there, at 2,500 on a smooth descent all the way down, unless ATC tell you otherwise. And then approximate distance to touchdown are indicated in the brackets, so you can see there, 30 nautical miles, 24, 20, 13, that's 10, and then that's 7.5. Very, very simple. That's just for noise abatement, so don't worry about that just yet. And procedure not suitable for RNAV coding, so don't worry about that because we haven't done anything to do with RNAV. And there you can see that massive restricted airspace, which I'm sure if you're familiar with London, you probably know what that is. That's the Canary Wharf area, that's Canada Square, the financial area, tall buildings. This is mostly for helicopters actually, because of the amount of traffic that flows in with aircraft. It's mostly for helicopters, and this area is special for, I think, Metropolitan Police. So the helicopters are given special dispensation to get into these areas. And last but not least, UNL means unlimited. That's all that means. So this just extends all the way up. Don't have to worry about that until we're looking at airspace. Hopefully that gives you a good idea as to your initial approach procedures and how to use the Bovingdon star. So this one over here, and in fact any other star, they are all exactly the same. Thank you very much for watching. Please remember to hit the like button if you like this video. Subscribe to the channel for more videos on the ground up advanced flight tutorials. If you're watching this on Twitch, thumbs up and a follow please. And do consider supporting me on Patreon. Link to that is in the description box below, or you can just visit www.patreon.com/ecgadget. Leave a comment letting me know if you understood this and if the explanation was okay. Next video is going to be the last one, and that will cover, or the last one of the charts, and that will cover this point from the final approach fix to landing at London Heathrow. Thank you very much for watching once again, and I will see you guys next time in the ground up advanced flight tutorials.